Notice that we can have paths that are non-simple even if the graph is simple. Okay, let me give you an example. I'm going to go the whiteboard. Imagine, for instance, that we have a graph like this one here. Very simple graph. We have only one connection between each pair of vertices, so the graph is simple, but we can have a path that goes from 1 to 2, then to 3, then to 1, then to 2. And we are repeating this edge here. So even if the graph is simple, the path that we have constructed is not simple because we are repeating an edge. Okay, so be careful with that, because we are going to talk about different types of paths and whether they are simple or not, and we need to take into account this kind of situation. Okay, also a very important type of path that we are going to use many times is what we call a cycle. A cycle is a path in which the initial and end vertex are exactly the same. Okay, so we start and we end in the same point. This is something that we have already studied when we were trying to determine whether a grammar generates or not an infinite language. Remember that we used a graph, a directed graph, okay, from the grammar in Chomsky normal form with no useless symbols. We draw a graph, and then we studied whether the graph had cycles or not. The definition of cycle is this one here. The idea of cycle is this one here. A path, a set of arrows that goes from one vertex to the other and starts and ends in the same place. Okay? And again, a cycle is said to be simple if its edges are all different. Going back to our example, we can have cycles which are simple and not simple. For instance, if we define the cycle 2, 3, 1, 2, this cycle is simple because it starts in 2, uses this edge, then this edge, then this edge, each edge just once, and then it is simple. But I can have something like, for instance, 2, 3, 1, 2, 3, 1, 2. And I'm using each edge in the graph twice. Okay, so this is a simple cycle, but this cycle is non-simple. Okay? The difference is that in one of them, in the simple cycle, I only use each edge once, but here I use edges more than once. Okay, that's the difference between one concept and the other. Okay, so that's all for today, and next time we are going to study how to represent graphs as data structures in order to be able to work with them in the computer and develop algorithms. That, of course, is what we are interested in, to develop different methods, different algorithms to study properties of the graphs, and then to have to deduce some information about the problem that we are studying. Thank you very much for your attention. As always, if you have any question, please feel free to use the discussion forum or to send me an email. And see you next time.